In this video, we will study equivalent circuits. We begin with the definition of equivalent circuits. Two different circuits are equivalent at a pair of terminals if the voltage and current at this pair of terminals is identical for both circuits no matter what is connected to them. For example, we show two circuits called circuit 1 and circuit 2. Each of these circuits has a pair of terminals A and B coming out of the circuit. The terminals A and B are the pair of terminals that we are referring to in the above definition, at which the two circuits are equivalent. The voltage and current that we are interested in is at this pair of terminals at nodes A and B. For example, the voltage V1 may have the polarity as shown, and we will get the same voltage V1 at the second circuit. The current flowing may be in the direction shown as I1, and we will have the same current I1 in the second circuit. For example, if we do not connect anything to the two circuits, then I1 will be 0 for both circuits, and we will have a voltage V1 across nodes A and B for both circuits. If we connect anything else, for example a resistor between terminals A and B of value R, we connect the same resistor across terminals A and B of circuit 2 as well. Then once again the voltages V1 and the currents I1 will be equal. In fact, no matter what we connect between the terminals A and B, the voltages V1 and I1 will be the same for both circuits. If the voltage V1 and I1 is equal, no matter what we connect to the two circuits, we say that circuit 1 is equivalent to circuit 2, and this equivalence is shown by drawing the equivalence symbol between the two circuits, which indicates that the two circuits are not equal, but they are equivalent at the pair of terminals A and B. We will also note some properties of these circuits. The first property is that only the behavior at the pair of terminals is identical. The two circuits may have different voltages, currents, and power dissipation inside them. The second property is that an element is either completely inside the box or outside the box as shown above for both circuits. For example, we cannot have a resistor connected from inside of circuit 1 and then connected to the outside of that box. This is because if we have this resistor R2 coming from within circuit 1 to the outside, then we really have three nodes that are coming out of the circuit, for example A, B, and C. And the equivalence that we are studying in this course is at a pair of terminals only. Therefore, we will not allow for such connections when we are considering the equivalence of two circuits. Another common situation that we have to be careful of is control sources. So for example, we cannot have the control source to be partially inside the circuit. For example, if we have a voltage Vx inside circuit 2, we cannot have a controlled current source which depends on this voltage and is outside the circuit. This voltage controlled current source is considered to be partially inside the circuit too. Therefore, we will not allow such elements or element connections either. To summarize the definition of equivalent circuits, the two circuits are enclosed